Good afternoon, everyone. And today, by this video, and I want to discuss the introduction about the network layer. And I am Naveena from the Department of Cybersecurity in the Institute of Aeronautical and Engineering, Dundigal. Today, I want to discuss the topics of related to the introduction of the network layer. In this, I want to discuss the functionalities and responsibilities of the network layer and the network layer designing issues. In that one, the addressing and the queuing and internet working, delivering how to deliver the packets while transmitting from one layer to the another layer. And after that one, the packet switching and the circuit switching and the services provided to the transport layer and the connection oriented and the connectionless oriented services and implementation of the connection oriented with the examples and implementation of the connectionless oriented with the examples and implementation of connection oriented by means of two ways, either by means of circuit switched connection. Second one is the virtual circuit switched connection. And after that, the differences between the virtual circuit along with the datagram. And today, and in my first topic, I want to discuss what are the main functions provided by the network layer. Hence, I want to discuss that network layer is present. It is one of the important layer which should be present under the OSI reference model. Out of the 7 layers, this is one of the last but third layer which should be present in the OSI reference model and which should be playing a vital role for transmitting the data packets from one node to the another node in a successive mode. So the functions of the network layer before that one, and where is that network layer was situated. So the location the network layer was situated is in between the data link layer and the transport layer. The network layer is situated between, under the OSI reference model, there should be 7 layers should be present. 1, 2, 3, 4, 5, 6, 7. Out of this, the last one is the physical layer. The upper one is the data link layer. After that one is the network layer. And the upper one is the transport layer. So these are the layers which should be present by means of a OSI reference model. So in my previous videos, I have already discussed related to the OSI reference model and the important layers of the OSI reference model and what are the functions which should be present, performed by each and every layer, and how the packet transmission it would be coming or done from one layer to the another layer. So today I want to discuss about the network layer and the functions of the network layer, and the second topic is nothing but the network layer designing issues. Let us see what are the functions of the network layer. And I want to define initially, first of all, where is the location of the network layer. The network layer is present in between the, as I have already explained to you, in between the transport layer and the data link layer. And the services means the network layer can provide the services to the transport layer and it shall able to utilize the services from the data link layer. It will provide the services to the transport layer and it will utilizes the services from the below layer, what I call it as a data link layer. So coming to the functions of the network layer, the first one is the routing. Routing means for the transmission of a packets, it will have a need to check one route or to find one path. That path, whether it is a physical connection or a logical connection, that's a particular path which a packet can able to transmit from one node to the another node, from one node to the another node, or from one source to the another destination. A data packet can able to transmit in a particular path. So this path, what we can call it as a routing. Routing means finding a path to transmit the packets from one host to the another host, or if you can define in second way, and it is nothing but a logical connection, a physical path which should be established to transmit the data packets from one source to the another destination. This is one of the functions which should be organized by means of a network layer. Coming to the second function of a network layer, congestion control. So congestion control, it is nothing but the mechanism to prevent the host from flooding the network. So let us see the example of congestion control. If a class consisting of, the class is capability of taking the intake of students 60 people, suppose if you can assume. So if one class consisting, and due to the insufficient of the classrooms or whatever the problems it might be, so if you want to accommodate the two sections in a one classroom, so that condition what we can particularly call it as a congestion control. Like that only, if the data packets can able to transmit it on a one particular path or a logical connection or a physical path, so they are ready to transmit it from the source node 1 to the destination node. So the data packets are about to move or ready to transmit it by means of a data packet 1, data packet 2, data packet 3, data packet 4. Suppose if you can take the example of data packets transmitting from one source node to the another destination node. So these packets are about to transmit from one node to the another node. So the source node is about to send all the data packets. The destination node can able to receive those type of data packets which will be received by means of a one source, and it can able to give the acknowledgement to the concerned source router. So this type of, you can already send 5 type of data packets as I have received those type of packets in a successive mode. So that is nothing but one of the successive rate of transmission of packets from one source to the another destination. So while transmitting the packets, what was happen sometimes the data packets will not get acknowledgement. Why? Because due to the rush or heavy flow of data packets continuously without get the acknowledgement back to the concerned source. So at that time, that condition what we can call it as a congestion control. Simply if you can define in another way, without getting the acknowledgement of a incoming data packets by means of a destination host to the concerned source host is nothing but the congestion control. Continuously the source 1 or a node 1 can able to send the data packets to the destination, and the destination packet was unable to send the acknowledgement of a incoming data packets to the source node due to the heavy flow of a data transmission of packets from one node to the another node. This condition what we can call it as a congestion control. And already in the networks, and they can detect most of the error detecting techniques to control the congestion control as well as the flow and heavy control of data transmission of packets from one node to the another node. So coming to that, the third functions of a network layer is nothing but the quality of services, and we can abbreviate it in a smaller form, QoS. So it is nothing but the transmission rates per bit and the error rates and the other characteristics can be measured under the QoS. And it is, if you can define, it is nothing but the improved and to some extent guaranteed in advance. So while transmitting the data packets from one node to the another node, while you are working with under the network layer, so we can able to calculate the bits of data packets or the data frames or the data bits from one node to the another node. We need to send it, or a host 1 can able to send it by means of under the transmission rates to check the error rates, and other some of the characteristics might be influenced. Those can be measured or need to be considered for the value of a quality of service. So coming to that, the fourth functionalities of a network layer is nothing but internet working provides. So an internet working means it provides translation between subnet using different protocols. What I mean by subnet? Subnet means it is nothing but the collection of all the hosts. Subnet is nothing but, if you can take the example of subnet, so a LAN is a collection of one subnet which will be interlinked with many hosts. Host 1 and host 2, host 3, host 4, if you can take the example of subnet. So a subnet is nothing but it is a collection of number of hosts or linked with many number of hosts. It is what we can define it as a subnet. So internet working provides the translation between the subnet which can able to connect the different hosts by means of using different protocols. And the last one is nothing but the error control. Error control it is one of the most functionality and of a network layer. what we can call it as a error control. What do you mean by error control? While transmitting the data packets from one source to the another source, so all the data packets they are about to move or they are traveling on a one physical path or a logical connection which should be established for the transmission of the data packets from one node to the another node. So what was happened in the middle, if any bit it was disrupted or does not hold any IP address, so whether any bit it will be corrupted, that bit will be identified by means of a CRC checking codes or some error detecting codes. That bit will need to identify it and take it out that bit and resend it to the concerned sender. This concerned source router or source route will need to check it and retransmit the bit again in a regular mode of path of communication. This is nothing but the error control of one of the functions. It is one of the functions which should be obtained or played by means of a network layer. So these are the nothing but the functions or the vital roles played by the network layer. So coming to that, the second concept and the most important concept is nothing but the network layer designing issues. And what are the network layer designing issues means? It will be consisting of many type of design issues. What we can see means network layer functionalities. The first one, second one, addressing. The third one is the populating routing tables or static routes, queuing, incoming and outgoing data, and then forwarding, and internet working between two different subnets, as I already explained in my first functionalities of the network layer, and delivering the packets in effective mode from one node to the another node, and provides the connection oriented as well as the connectionless oriented while transmitting the data packets from one source to the another destination. So coming to that, the network layer functionalities, the devices which work on the network layer mainly focuses on the routing. Routing means establish a physical path or a logical connection which can data packets successively or consequently able to transmit from one node to the another node. The first node what we can call it as a sender, the second node what we can call it as a destination. This type of routing may include the various tasks which should be aimed to achieve a single goal. Those can be organized or referred or defined in another way. The first one is the addressing devices and networks. And second one is the populating routing tables or static routes. The third one is the queuing of incoming data packets from one node to the another node as well as outgoing data. That means those packets which can be received by means of a destination, those will have a need to get that acknowledgement again to the concerned sender. Next. So after the queuing has done by means of incoming as well as outgoing data and then forwarding them according to quality of services, what we can call it as a QoS constraints set for those packets. So coming to the last but second one is nothing but the internet working between two different subnets. Means a subnet is a collection of many number of hosts. So if you can take the two subnets, subnet is a interlink connection between the two type of switched networks. So delivering the packets to destination with best efforts. With best efforts means while transmitting the successive level of data packets from one source to the another destination. With best efforts means the destination part or the receiver needs to send the acknowledgement to the incoming data from the source router or a node 1 to the node 2. So that's point what you can define here by means of delivering the packets to destination with best efforts. It provides the two types of connection. So the first one is the connection oriented, second one is the connectionless oriented. So coming to this, the second element of a network layer design issues are nothing but the store and forward packet switching. In this, the store and forward packet switching means restating the context of network layer protocols, and second one is the services provided to the transport layer, implementation of the connectionless service, implementation of the connection oriented service, comparison of virtual circuit and the datagram subnets. So store and forward packet switching, it is one of the first important topic under the store and forward packet switching. So in that, the data is The first one, in that the data is divided into smaller parts, what we can call it as a packets. Here in the network layer, the mode of transmission of a message is by means of a packets. That means the data, what is in the form of in the bulk mode or in the longer mode only, they can able to split it into packets, data packet 1, data packet 2, data packet 3, data packet 4, like that only. Okay. So data is divided into smaller parts, what we can call it as a packet. That means we need to identify, we have to see the type of mode of transmission of the data in the form of a data packets under the network layer. So coming to the second one, the packets are transmitted from one node to the another node, processed and forwarded. Successive route will be obtained or any source path will be having by means of a network layer from one node to the another node. That means when a packet needs to transmit from one node to the another node, definitely a path or a logical connection will need to establish before transmitting the packets from one node to the another node. So the third point is nothing but, and it is also known as store and forward switching. Why? Because it will be having the two type of connection types. The first one is the connectionless datagram. Second one is the connection oriented datagram, what we can call it as a virtual circuit. So why we can call it as a store and forward switching means, so whenever the source node can able to transmit the data in the form of a under one physical path which would be established by means of a network layer. So all the packets, they can come before that only, they are able to transmit and store it at the source node. After that only, they can able to transmit, starting the traveling through the logical connection or a path from one source to the another destination, or from one sender to the another receiver. This is what we can call this condition, storage of the data packets and forwarding the packets from one node to the another node. This condition, what we can call, mentioned or identified under the network layer design issues, what we can call it as a store and forward procedure or store and proceeded forward packet switching. So coming to that, the third important vital role played by the network layer design issues is nothing but the services provided to the transport layer. So as I have already explained while entering of this, or the initial points of what I mean to mention under the network layer design issues, by means of functions of the network layer, the services provided to the transport layer. As I already told to you, that explained by means of services provided to the transport layer means the network layer is situated between the transport layer and the data link layer. So it can provide the services to the upper layer, what we can call it as a transport layer, and it can utilize or consumes the services, what we can call it as from the below layer, data link layer. So here we can see one by one the services provided to the transport layer. The first one is the services should be independent of a router technology. Second one is the topology of network should be hidden. The third one is the network addresses available to transport layer should be uniform even across LANs and the WANs. So network layer designers have freedom in the mode of writing specs of services to the transport layer. So the first one is the services should be independent of router technology. There is no identification or depending of any router. We could not find any type of router for the transmission of data packets from one source to the another destination under the services provided by means of a transport layer. So second point is topology of network should be hidden. Topology means here the many type of topologies we have already studied in our previous modules, like ring topology, bus topology. So those type of topology of networks we should not identify while you are working with network layer designing issues. The network addresses available to the transport layer should be used uniform even across LANs and WANs. That means for every data packet it should be holding some network address. That means if you are connecting the LANs and WANs in the mode of a subnets, So these LANs or WANs must needs to hold some network addresses. Those network addresses available to the transport layer, that means whatever the above layer of a network layer means transport layer, the network addresses, those should be available under the transport layer. These network addresses should be uniform and unique, and those are same. While if you are taking the consideration of network layer only, when the data packet is transmitted from the transport layer to the network layer, it will follow the same type of network addresses, and the LAN and WAN connections also should hold the same number of network addresses only. That is the point we need to remind. It is one of the third element under the services provided to the transport layer. So coming to that, the last one is the network layer designers have freedom in writing the specs of services to the transport layer. So coming to that, the next element or the next topic of a network layer design issues are nothing but the connection oriented and the connectionless oriented. So in this we have to identify the two types of way of communications. The first one is the connectionless, second one is the connection oriented. So the internet community consisting of the connectionless, that means this is one of the internet community is one of the examples for the connectionless oriented services. And whereas, so this is the example of a connectionless oriented services. In this, the router's job is only moving the packets and nothing more than that they can do. Simply they can able to transmit the packets from one node to the another node. That is the first point. And second point is subnet is inherently unreliable. There is no reliability by means of connecting the hosts by means of a subnet. Subnet connection is there, but it should not consisting of any unreliable, not reliable content. So hence the term what we can call it as inherently unreliable. So the third one is the host should provide error and flow control. There should be some techniques of to detect the erroring bits and flow controlling of heavy bits. If there is any corruption and disruption of the bits while transmitting from one node to the another node, that should be identified by means of a error detecting techniques, what we can call it as a CRC and cyclic codes, checksums, like that only. So this is nothing but host should provide error and flow control. So coming to that, the connection oriented, what we can call it as a, the connection oriented is the example of a telephone companies. So if you can take the example of in the olden days, the telephone communication or the telephone companies is one of the example for the connection oriented. Here the subnet should provide reliable service and successful experience with the connection of subnets providing the reliable service with telephone systems. And after that, without the connections, the QoS is hard to achieve while we are working with connection oriented. So the telephone companies or the telephone communication system is one of the examples for the connection oriented. Why? Because it can provide the reliable services by having the inherent subnet should be provided with many hosts. This is one of the two examples by means of a connection oriented as well as the connectionless oriented. So coming to that, how the implementation of the connection oriented services under the network layer designing issues. The first one is the path from source to destination must be established before if any sender or source router can need to send the data from one node to the another node. That means a path, a physical connection or a logical connection need to be established before sending the data under the network layer. Next one, the connection is called as a virtual circuit. Here, the connection, the mode of connection between one node to the another node, what we can call it as a virtual circuit. Here, the analogy with physical circuit in phone systems means the why it should be virtual. So that means there should be some of the reasons we should be meant for why the connection should be virtual while you are working with our mobile phone systems. Avoiding choosing new route for each packet and same route used for all the packets in connection, and each packet has its own ID for which the virtual circuit it belongs. Each packet should have the same ID. The packet it can be transmitted from one node to the another node and it will detected to which virtual connection it needs to be belong, or it needs to be transmitted to which virtual connection it belongs to. This is nothing but the implementation of the connection oriented. So coming to that implementation of connectionless oriented, here we have to see and need to identify some of the points under the implementation of the connectionless. That is nothing but the no connection setup is required. Connectionless means no path or no logical connection we have to identify. No path or no logical connection or no physical connection should be established. We never ever seen any such type of path. No such type of path should be entertained by means of a connectionless oriented. And message should be broken by means of a packets, what we can call it as a datagrams. Here, the type of messages, those are ready to be transmitted from one node to the another node is nothing but the datagram. The type of data packets, what we can call it as a datagrams here, network layer designing issues of a connectionless oriented services. So each packet is individually routed from one node to the another node. So here the routers decide the line based on routing table. Based on the routing table elements, the routers decide and the data packet it belongs to which line, and the data packet 2 is belongs to which line, data packet 3 is belongs to which line. Suppose D1 due to D3, if you can take this datagram packet belongs to which line according to the routing table and where it should be related, and data 3 it related to the which line. So this is nothing but the routers decided line based on the routing table. And packets can able to follow the different types of paths. That means a source route only can send the data packets, what we can call it as the datagrams. They can able to go to the destination or reach the successive destination by means of any different paths. So not guaranteed to arrive in order. Whether every packet need to go to the destination in a different path, whether they have to follow the same path, they have to arrive in a successive consecutive mode to reach the destination. We did not give any guarantee under the implementation of the connectionless oriented services. So these are the main points which should be included under the implementation of the connectionless services. So coming to that, the two ways of communication under the implementation of the connection oriented. The first one is the circuit switched connection. Second one is the virtual circuit switched connection. The first one is the circuit switched connection, means here we have to identify a dedicated physical path of a circuit is established between the communicating nodes, and then the data stream can able to transmit from one node to the another node. That means a dedicated path, a dedicated physical path we need to identify between the two communication nodes. This is the node 1 and this is the node 2. So this is nothing but circuit switched connection. Secondary virtual circuit switched connection is nothing but the data stream is transferred over a packet switch network in such a way that it seems to that user, and there should be a dedicated path from one sender to the another receiver. And here a virtual path, the name itself reveals that a virtual path is established here, while the other connection may also be using the same path. First of all, we need to establish a virtual path from one node to the another node, and here the data stream, that means stream means the number of datagrams or the bulk of datagrams, the group of data packets can able to transmit or transfer over these type of dedicated path from one sender to the another receiver, and this path may be established and may able to transmit the data packets from one node to the another node. That means while other connection may also be using the same path. That means the other type of datagrams, those who are ready to travel in other direction also, if the data packets are moving forward, so they can also, if the route is free, they can also able to transmit or use this path from one node to the another node. That is nothing but the virtual circuit switched connection. Here we need to identify, establish the virtual path connection established. Here we need to identify that type of connection, while virtual circuit switched connection of implementation of two types of connection oriented under the network layer designing issues. So coming to that one, virtual circuit with datagrams. So this is nothing but the main difference between the virtual circuit with datagram. Nothing but a virtual circuit means it allows the packets which contains the shorter ID. Each packet should having one ID and one IP address. The ID is meant by means of some number like ID 1, and IP address means suppose it is nothing but V6 and V7 and V8. This is nothing but the IP address, and ID is nothing but by means of giving the numbering, and I1 and I2 and I3 like that. So a virtual circuit means which can allows the packets to contain the shorter ID. A datagram must contain the full destination address for shorter packets and significant overhead OT, OH, and a virtual circuit needs the table space in the routers while forming the subnets, working with the network layer from one layer to the another layer. So coming to that, the datagram subnet, it needs entry for every possible destination. The VC subnet just needs an entry for each virtual setup connection. So, but VC setup packet have to be routed as usually. So here a virtual circuit means, again I am explaining, you need to explain you, it allows packets to contains we should be having the shorter ID as well as the IP address. And a datagram must contains a physical path which will hold the destination address for the short packets, significant overhead by means of a OT, OH. So coming to that, the network layer designing issues, the main differences between the virtual circuits and the datagram network played by means of the designing issues of the network layer designing issues. The first one is the definition. A virtual circuit is a connection oriented circuit service in which there should be implementation of resources like buffers, CPU, bandwidth, and the parameters, the transmission bits and the error bits, detection of the error bits used by virtual circuit for a data transfer from one node to the another node. So coming to that, the datagram network, on the other hand, a datagram is a connectionless service, and where no such sources are required for the data transmission. Here, this is a connection oriented, that means it will be having a particular path and it does not require any path, does not hold, not required any path. That means hence we can call it as a connectionless service. Connection oriented means it should be having holding some logical connection or physical path before transmitting the data grams or data packets from one node to the another node. That is one of the main definition between the virtual circuits as well as the datagram network. Coming to that, the second one is nothing but the path. So mainly if you can discuss or if you want to make the differences between the virtual circuit as well as the datagram network, the path, whenever the path is established or any logical connection is established before transmitting the data packets from one node to the another node, that what we can call it as a connection oriented, and that is the example of a virtual circuit. Other side, which does not have any path for the data transmission from one source to the another source, that network what we can call it as a datagram network. So here, if you can identify, it means the path means n number of virtual circuits as well as all the resources and bandwidth get reserved before the transmission. What do you mean by a bandwidth? The bandwidth is number of bits or a number of frames can able to transmit bits per second. The number of data packets or data frames or data bits can able to transmit it under the bits per second, what we can call it as a bandwidth. So it will be getting reserved before the transmission, and the path which should be utilized or followed by first data packet would get fixed, and all the other data packets, they can use the same type of path to reach their destination by means of consuming the same path in the same mode only. So coming to that, the other side of a network, what we can call it is the datagram network. On the other hand, in case the datagram network, the path is not at all fixed or certainless, as data packets are free to decide which path they need to transmit from one node to the another node to reach their successful destination, or they can able to select any intermediate path router. They can go dynamically changing their routing tables to reach their destination. So here we could not identify any type of path under the datagram network. Here one particular source path and an established connection will need to identify by means of a virtual circuits. The first one is the path should be established, and the implementation of bandwidth and consideration of some parameters like buffers and virtual circuit and the data transfer. Those are all some of the resources which should be implemented while you are working with virtual circuits. Whereas the datagram networks, we could not find any such type of parameters while you are working with the datagram network under the network layer. We could not identify any type of bandwidth and CPU buffers and any type of the transmission parameters from one node to the another node by means of your working with the datagram network. And nothing but, and again I need to recollect, and the means of the functions of the network layer is nothing but, the first one is again the routing means, and it can able to select one successive path or a physical communication or a logical connection from to send the datagram packets from one host to the another host. So second one is the congestion control and the error control, and to avoid the heavy flow of a data packets from one node to the another node, and the quality of services by means of a transmission rates, error rates and other characteristics can be measured and improved to some extent by means of a guaranteed in advance. And we are highly seeing the subnets here by means of providing the connection, internet providing the connection which can able to translate between the two types of subnets. If you take the example between the LANs and the WANs, we need to take the two types of subnets. That means LANs is meant for the one subnet and WANs is meant for the second type of subnets. The two type of subnets and their working procedure, the establishment of the internet connection between the two types of subnets, we have to identify it by means of a network layer. These are the main functionalities or the responsibilities of a network layer. The first one is the routing a path, second one is the congestion control, third one is the error control to avoid the error detected bits and to discard those bits, heavy flow of datagrams or data packets from one node to the another node to get a successive acknowledgement to the source router again, and the quality of services and the internet working. And thank you. Up to this video, at the last of this video, the students can able to identify and the outcome of this video under the network layer design issues is nothing but, and how the route will be established and how we can able to identify the connection oriented and connectionless oriented, what makes the differences between the virtual circuit as well as the datagram circuit, and the examples of implementation of a connection oriented as well as the connectionless oriented. Thank you. Keep watching of the network layer, the second module of a upcoming video. Thank you one and all.
Like, share and subscribe. Hit the bell icon for more updates.